As we recently discussed, testing is an important part of the software development process in which you try to find the bugs in your code. During this process, your goal is to find the bugs in your code, so remember that a good test case is one that the code fails. You want to find the bugs that are in the code. When your code fails these test cases, you fix the problems, then test again. As you fix the problems in your code and pass more test cases, you become more and more confident that your code is correct. Of course, no amount of test cases can ensure your code is correct, but with a nice set of good tests, you can become very confident in your code. Now, we want to take a moment to talk about how to make good test cases. There are two major methodologies that go hand in hand. The first is called black box testing. With black box testing, you do not look at the code. You might even write the test cases before the code exists. Instead, you look at the problem statement and think about various behaviors that need to be tested. Here, it is especially good to focus on things that might go wrong. The other major methodology is called white box testing. Here, you are looking at what parts of the code were covered by a set of test cases. Covered means that the test cases went through a certain part of the code. You may find that some parts of the code were not covered. For example, the then clause of an if statement was never entered because its condition was always false. These untested parts of the code are likely places to have bugs as they have not been tested at all. In white box testing, you look at what parts are not covered and use them to think up new test cases which cover those parts of the code. In black box testing, you only consider the expected behavior. You don't know the implementation details, which is why the approach is called black box testing. The piece of code you are testing is a black box. You cannot see inside it. Here, we have depicted this idea graphically. There's some function f, and you expect that when you give it inputs of x equals 3, y equals 4, and z equals 0, you will get out an answer of 37. You expect this answer no matter how f is implemented because that is its correct behavior. Of course, in thinking about what test cases to make, you should think about the range of behaviors that f can exhibit, and also try to guess what mistakes a programmer might make in implementing f so that you can have good test cases. As a concrete example of this, imagine the power function which computes x to the y power. We know the function will take parameters x and y and return an answer, but we do not know what the implementation looks like. One way we like to encourage new programmers to think through black box testing is by making a little worksheet where you describe each test case, saying what mistake you think a programmer might make, what input you want to use to test for that mistake, what output you expect to get if the program is correct, and what output you expect to get if the mistake were made. For our power function, we have two examples of such test case planning here. In the first, we think a programmer might have a misunderstanding of the domain knowledge involved in the problem. A number raised to the 0 power is 1, but some people might mistakenly think that it is 0. We describe such a mistake and give an input like x equals 2 and y equals 0 that would check this behavior. If the program is correct, the function will return 1, and if the function is wrong in the way that we are thinking, then it would return 0. We also describe a second test case here. We know that off by 1 mistakes are quite common in programming. These are where we make a computation that is either 1 too high or 1 too low. In this case, we are thinking a programmer might write a loop and do it 1 too many times, computing x to the y plus 1 instead of x to the y. If we test with x equals 3 and y equals 3, we expect to get 27. If this particular error exists, we will get 81 instead. We want to underscore that if you get any answer other than what is expected, your test case detected some bug, even if it was not the bug you were thinking, so it is a good job. However, thinking about the answer your test case would give if the bug is present is still quite important. You want to make sure that it is different from the right answer. Contrast the previous test case with this one. If we try to test for the same mistake with x equals 1 and y equals 3, our correct answer is the same as the answer we would get if the programmer made this mistake. That means that this test case is not a good way to detect this particular potential problem. These inputs may still be good test cases for other reasons, but they would fail to identify this particular mistake. An important consideration in testing is to make sure your error handling works correctly. Programs often have to deal with inputs that are invalid or otherwise problematic. How they deal with such inputs depends greatly on the particular program, but in testing we want to make sure these error cases are dealt with correctly. When you think about testing for error cases, think about what inputs are invalid and why. Come up with test cases that cover all the types of errors that you can think of. When you do so, try to come up with inputs that are as close to valid inputs as possible. If your program expects exactly 10 things, the best error cases to test for are 9 things and 11 things. Another important consideration is to only try to test one error per case. To see why, imagine a program that requires 10 cats and 14 dogs as inputs. What if we decide to try testing both too few cats and too many dogs in one test case by passing in 9 cats and 15 dogs? Think for a moment about what a correct implementation would look like. We'll check the first error case, such as the number of cats, and then deal with that error. In this example, we are dealing with this error by printing a message and exiting. The code to check for the correct number of dogs comes after this check, so it will only be executed if the number of cats is correct. If the number of cats is incorrect, we will never even execute the code to check the number of dogs. If there were a mistake in the code to check for the number of dogs, whether in the condition or in the way the error is handled as shown here, we will never find out. Our code won't reach this part because of the error handling for the number of cats. We'd want to test with 10 cats and 15 dogs to check this behavior. While we want to be sure to check error cases, don't forget to test for the behavior of valid inputs too. Many novices get fixated on error cases, but testing the behavior of valid cases is critical as well. We want our code to work correctly on these cases too. As always, remember that hard test cases are good test cases. Think about what could go wrong and come up with test cases that will make you confident the code is correct once it passes your test cases. We'll give you a reading right after this with a lot more information about how to think of good test cases. We also mentioned white box testing. You'll learn more about that idea later, where we'll want to see how much of the code was covered and think up test cases to fill in the gaps in our coverage.